Hello everyone, welcome to video lectures on textile chemical processing. And this is Dr. N. Gopalakrishnan, Assistant Professor, Department of Textile Technology, Banana Institute of Technology, Satyamangala. Before going to the topic, let's see some pictures that relates to your topic. The first picture, that is lotus leaf with water, and everybody knows the concept of lotus leaf. Normally lotus leaf will hate the water. And in the second picture, a fabric that has some uneven dyeing. So that dyeing is done in a proper manner, but that produces uneven dyeing. So there is a relation between these two pictures and two concepts, and that's our today's topic. So if the fabric doesn't absorb water, then it produces uneven dyeing. So that's what I want to say with this picture. And today's topic is scouring. So scouring is a process to remove the natural impurities present in the cotton fiber. The natural impurities like oil, fat, wax, pectins, mineral matter, and other impurities like ash and seacoat fragments, all removed by scouring. And still, some impurities are present or even after scouring process. That may be a natural coloring matter that can be removed by bleaching treatment. So, so the today's topic is scouring. So we will see in a detailed manner. Scouring. So scouring is a process to remove the natural impurities like oil, fat, wax, pectins, mineral matter, ash, and other seafood fragments are removed by scouring. Naturally, the cotton fiber will have a lot of impurities, and that is removed in the preparatory process. And during the fiber manufacturing or yarn manufacturing, we add some reagents that may be useful for the particular process, but that may not be useful for the subsequent process. Like we use spin oil for lubrication in spinning, and that may be useful for a spinning process, but that is not useful for processing industries because that hinder the absorbency of the cotton fiber. Similarly, we use starch in weaving department to improve the strength and flexibility of the yarn during weaving, and that may improve the weavability of the fabric, and that is useful for weaving, but that also hinder the absorbency of the cotton fabric during processing, or that means during dyeing and printing. So we have to remove these impurities before dyeing and printing, and along with natural impurities. In the first video lecture, we have learned how to remove the protruding fiber present in the cotton fiber or any textile fibers. There are three methods. One is shearing, that means cutting the protruding fibers, and in second method we saw singeing. So singeing is a process to burn the protruding fibers, and third method we are removing the protruding fibers by dissolving, by using some enzymes, so that is biopolishing. So there are three methods, but in our syllabus we have only shearing and singeing, and biopolishing we will see in the latter stage of the process. And in the second video lecture we have learned how to remove the starch or size present in the fabric. So there are two methods to remove this starch or size present in the fabric. One is hydrolytic method and oxidative method. Hydrolytic method, again, it has three methods: rod strip, acid stripping, and enzymatic stripping. And each has its own merit and demerits, and we have seen all those things in the previous videos. And oxidative method, you can use oxidizing agent to oxidize the starch present in the fabric. Hydrolytic method is useful for natural starch, and it is more effective against natural starch, whereas it is poor against the synthetic starches like PVA. And the oxidative methods like sodium hypochlorite or any oxidizing agents, that is more effective even on synthetic starches. So you can use oxidative desicing method for synthetic starch as well as natural starch. But if you take hydrolytic method, it is not useful for synthetic starches. So you have to go for oxidative method. So these desicing methods remove the starch present in the fabric, and it can't remove the oil, fat, wax, pectins, and other impurities. So you have to go for different process. So that is called scouring. So scouring will remove the oil, fat, wax, pectins, mineral metals, as and other impurities, except natural coloring metals that are removed during scouring process. At the end of this class, you will be able to analyze the mechanism involved in removing the oil, fat, wax, and other impurities present in the cotton fiber by saponification and emulsification method. To achieve the general objective, I framed three specific objectives, like you are able to explain the process of wetting, and you can able to explain the process of removing the oil, fat, wax, pectins, and other mineral materials present in the cotton fiber by saponification and emulsification method, and you can able to execute the process of scouring for various textile materials. Normally, cotton fiber consists of various impurities. Majorly, it is cellulose. You see the composition of cotton fiber, around 85 to 94% it is cellulose. So that is the pure fiber, and remaining 15 to 8% will be impurities. So this content may be varied, depends upon the type of fiber and nature of cultivation. And if the fiber has higher content of cellulose, then we call it as very good cotton fiber. And if it is lower content, it is poor cotton fiber. And the scouring process will remove these impurities like oil, fat, wax, pectins, proteases, and ash, moisture. All those things are removed during scouring process, and we'll see one by one. Natural fibers contain oils, fats, and waxes, along with some other impurities. Fats are derived from the trihydrate alcohol glycerol, and this is the general structure of the trihydrate alcohol glycerol. When the three hydroxyl groups are esterified with fatty acids of higher molecular weight compound, which is formed is a fat. And the fatty acids which are commonly found in natural products are palmitic acid, that is C15H31COOH, stearic acid, that is C17H35COOH, and oleic acid, that is C17H33COOH. The corresponding esters of fats are tripalmitin, tristearine, and triolein. And the general structure of the following esters are given below. When oils and fats are heated with a solution of sodium or potassium hydroxide, they are hydrolyzed into glycerol and the alkali salt of fatty acid. The sodium or potassium salts of the fatty acids are soaps, and this particular hydrolysis is therefore referred as saponification. Saponification. Saponification is a process in which soaps are formed using an ester and treating the ester with a strong alkali. The vegetable oils which has ester is treated with a strong alkali, either sodium hydroxide or potassium hydroxide. In the process, salt and glycerol is formed. The salt is nothing but the soap. Soaps are salt of sodium or potassium fatty acids. If you are treating the vegetable oil with sodium hydroxide, then it is a sodium salt. If you are treating with potassium hydroxide, then it is a potassium salt. If we take sodium hydroxide, the formula of a soap molecule is C17H35COONA. This salt is called sodium stearate. This is commonly used soap, and the other soaps are C15H31COONA, that is sodium palmitin, and another soap is C17H31COONA, so that is sodium volatile. Let's see about sodium stearate. The soap molecule is C17H35COONA. If you look at the soap molecule C17H35COONA, you will realize that there are two ends. The end C17H35 is carbon hydrogen chain, so that it is completely bonded by a covalent bond. All the carbons are bonded by covalent bond, but when we talk about COONA, this is the ionic part of the show, where Na is given electrons and COO is taken electron. So the sodium has positive radical and COO has become the negative radical. In the soap molecule, we have two ends. One is polar and another one is non-polar end. The ionic part of the molecule has polar end because it has polarity of plus and minus. And the non-ionic part is called non-polar end. So this one soap molecule can be drawn using a tadpole structure which has head and tail. The head represented the polar end, and that is COONA, whereas the tail represented the carbon hydrogen chain where C17H35. Whenever we put a soap molecule in water, the polar end dissolve in water because ionic compound, as we know, it will dissolve in water. And the non-polar end does not dissolve in water because it has covalent bond, and the covalent bond are not soluble in water Thus, the ionic part is called the hydrophilic part, and the non-polar end, that is non-ionic part, is called the hydrophobic part of the show. So, how do we define soap? Soaps are nothing but salt that can either be potassium or sodium salts. So the soaps are sodium or potassium salts of long chain of carboxylic acid. Let's move ahead and study the cleaning action of the soap. Before that, let us consider a mixture of oil and water. Will both oil and water mixed with each other? No. But if you put soap in this mixture, the oil and water start mixing with each other. That is because hydrophilic part dissolve in water and the hydrophobic part of the molecule dissolve in the oil. Because it is covalent and the oil is also covalent compound. Thus, the structure of molecule allows and water to mix with each other. Now, similar things happens when we clean our clothes with soap. Suppose we have dirt on a cloth and we have to clean this shirt with the soap. When we apply the soap on the dirt, the soap molecules start forming a group and the cluster of soap molecules called micelle. If we see lather and foam will indicate the formation of micelle. When we talk about a single structure of soap molecule is called tadpole structure. When all these molecules come together, then the structure is called micelle. In a micelle, the polar end always is attached with water, whereas a non-polar end goes to the dirt because the dirt is usually oil in nature. Now, when we rub the cloth, the micelle is removed from the cloth along with the dirt, and the dirt dissolve in water, whereas the cloth comes out clean and the water becomes dirty. This is the cleansing action of soap. Now, let us see what are detergents and how detergents are different from soaps. Because the molecule of a detergent, the ionic part is not COONA. Instead, it is SO4Na. Whereas the covalent bond is C12H25 C6H4. Here the C6H4 is a benzene ring. Thus the detergent is a sodium or potassium salt of long chain benzene sulfonic acid. Now the cleansing action of detergent is same as soap and it will form micelle. A group of detergent molecule having the polar end is attached towards water and the non-polar end is attached to oil. Detergents has strong cleansing action than soap. Around us, we have soft water and hard water. The soft water comes from glaciers which has no salt in it. But the hard water comes from sea or groundwater which has minerals and metal salts. Soaps is used with soft water will give lots of lather. That means micelle formation is proper and the cleansing action is strong. If you are using the soap in hot water, the half of the soap is wasted in reacting the soap with calcium or magnesium ions. This result in insoluble particle on the fabric that is called scum. This scum interferes the cleansing action of the soap and that reduces the cleansing action. When talk about detergents, the detergents do not react with the calcium or magnesium, so the cleansing action is strong even in hot water. So no scum is formed when we use detergent, but the problem is the detergents are non-biodegradable and cause water pollution. But the soap is but the soap do not produce much water pollution. Suppose we have two glasses of water, one is soft water and another one is hot water, and we do not know which is soft water and which is hot water. We can use soap to identify which water is soft and which water is hot. In a soft water, the soap will lather properly, but in hot water, it will lather less. But we cannot use detergent to identify the soft water and hot water because the detergents will lather properly in both kind of waters. Changes during scouring operation. Saponifiable oils are converted into soap. So that is covering action. And unsaponifiable oils and waxes are emulsified by soluble soap. So this is done by emulsification method. Proteins are hydrolyzed into soluble products by the action of alkali. Pectose and pectins are converted into soluble salts of pectic acid. So this is also by the action of alkali, that is sodium hydroxide. And similar amino compounds are dissolved or hydrolyzed to ammonia. Mineral matters and dirt particles are removed and held in a stable form. So all those things are by the action of alkali, except saponification and emulsification method. And this is the recipe for cotton scouring of cotton fabric. Caustic soda 2 to 3 percentage on one weight of fabric. Soda is 0.3 to 0.5 percentage on one weight of fabric. Sequestering agent 0.05 to 0.5 percentage on one weight of fabric. Wetting agent 0.24 to 1 percentage on one weight of fabric. Emistyle ratio, again it depends on the type of machine what you are using for scouring. If it is soft flow dyeing machine, it will be 1 is to 5, and if it is winch, it will be around 1 is to 15. If it is jigger, it will be around 1 is to 2, and if it is cured, it will be 1 is to 1. And temperature, it will be around 100 to 1 to 120 degrees Celsius for 2 to 4 hours. Again, all depends on the type of machine you are going to use. If it is winch, you can use the same recipe. If you are using for continuous process, you have to use higher concentration of soda ash and caustic. And time is also depends on the amount of alkali added in the process. Thank you, guys. And I think you have learned what is scoring and what are all the impurities are present in cotton fiber, and how to remove each impurities present in the cotton fiber, and you know what is saponification and emulsification, and what are all the chemicals are involved in saponification and emulsification process, and you know how to formulate the scouring process for various textile fibers. All those things you have learned in by this video lecture, and hope you have learned all those things. So thank you one and all.